Caelan, is time a construct?
It depends. It depends. And here's why. I've heard perhaps not compelling, but I've definitely heard arguments about how time is merely a human invention, and that time only passes and there's only regard for time when the idea of the human mind is brought into frame. So you can only ever think about time in regards to human perception of events. However, I think that that's still part of time, human perception, but also outside of human perception. It's kind of both. So you don't need it, but it's also there, if that makes sense.
And here's my thinking. Time definitely exists. I always hear this argument that time is a construct, and not to say time is relative, because that's a different argument that I think we can unpack. But to say time is a construct in the same way you just mentioned at the start, that there's no perception of time, so therefore time doesn't mean anything without humans. Not only is that anthropogenic, because I'm not sure that we're the only living thing in the universe, but even if we were, to say our perception is a requisite for time strikes me as incomprehensible, however you say it. Because whenever we weren't here yet, stuff was still happening. There was still movement along the path of space-time. Like, there was still the present moment in some billions of years of moments. So to say there's no time because there's no people experiencing it doesn't mean anything to me.
Yeah, and I believe that at the end of the day, what it's going to come down to is just defining precisely what we mean, and trying to unpack what other people mean. Because I've actually gone into this argument before with my uncle. He said that time is really only something that, as I said at the start, it's something that we made and therefore only revolves around our perception. But that doesn't explain, the 4.2 billion years leading up to where we are now on Earth with humans. So I mean, of all the animals and all the things that could have and probably did live here for all those years before, in theory, that they would have experienced no time. And I guess one of his interesting points is bringing up perhaps other animals' perceptions of time. But like you said, regardless of whichever lens we look at it through, it still happens, right? Is kind of what you're saying.
Let me give credit to your uncle. If he's mentioning that humans arbitrarily defined units of measurement to identify time, that I agree with. The second, the millisecond, the hour, the day, the week, that is almost totally arbitrary. I concede that point.
And I agree. I believe that is arbitrary as well, and I think that's actually what his argument was getting at. Not that time is a construct, but he says that it's a construct. So to more precisely understand what exactly we're talking about here, to say that time is a construct is to say that without humans it doesn't exist, right? So I'm going to say right off the bat, I believe it definitely exists with or without humans. Otherwise, I don't know how else you could explain the billions of stars. Did they just pop into existence as soon as the first kind of like half monkey, half human popped into sentience, or however that worked? So, I mean, I find it hard to believe personally. But other things we could talk about in regards to time and how we want to define it, because that's also very important if we're going to talk about if it's a construct or not, is kind of how it operates, how we're in this present moment, and how, whatever arbitrary minuscule amount of time we decide to choose that passes for it to become the past, and that future instant to become the present, if that makes sense. That was kind of hard to throw out of my mouth, but
Well, that hits on the point that I briefly mentioned at the beginning, that time is relative. We know this. You can look at astronauts who come back down from space and they're 5 seconds younger than their twins. And you think, how does that work? Right? Because time, we know, as you speed up, approaching the speed of light, your reality, your time happens the way you would expect it to, and everyone else's time happens the way they would expect it to. But if you're on a spaceship nearing the speed of light and everyone else on Earth is just still on Earth, and you go 100 years, let's say, in space, these are just arbitrary numbers, and then you come back, Earth might be 1,000 years older. You have, in some sense, traveled into the future relative to Earth. Now, that certainly can't be a construct, but understanding it is a whole different ballgame.
Yeah, for sure. And yeah, time relatively. I mean, even learning that time and space are connected is revolutionary, to say the least. And I'm not one to go into the specifics of that, because I'm no general relativist. Relativist. Thank you. That's the word. But it's definitely fascinating, and you see this topic being explored a lot. In I'm not sure if it's a popular topic anymore, but at least I remember in a few years ago, at the very least, the talk about, with movies like Interstellar coming out, I feel like that kind of popularized a little bit the idea of relativity and time, the passage of time at different rates. Which is interesting, and I'm actually so curious. I never quite learned enough about it to know the answer for sure. But the biological processes in the body is really the only thing that's affected, right? I mean that's how my brain looks at it. If you're near a black hole and space-time is warped so heavily that 1 second for you is so many thousands of times longer for someone relative to your frame. It's quite surprising that biology kind of respects that, which kind of alludes to the fact that it's definitely not a construct. But the best test we have of that, as you said, is astronauts being on the space station and then coming down and then being, like 1 or 2 seconds older or younger. I forgot which, but
does that freak you out at all? Because even though, admittedly, we're both not astrophysicists, you've studied a little bit more in aerospace, but insofar as our expertise, it doesn't lie in this. But does it freak you out at all, just on a human level, on a personal level, knowing if this reality is what we have, and let's say there was a God somewhere outside the fourth dimension, and maybe we need to define that a little better, but does it freak you out at all knowing that actually the rules aren't stable? There's an instability inherent to space-time. It's not that our reality is perfect and time works this way and this is the way God said it should be. Well, no, if you just go fast enough, if you approach the speed of light, or you could say go beyond the speed of light, but I don't know of any evidence to say we can do that, then there seems to be some kind of inherent instability and incoherency, and biology respects these things, but it shouldn't, right? You shouldn't get older than someone else faster than someone else, right? So does it freak you out at all on a deeper level that this is not only possible, but as far as I can tell, the evidence increasingly supports it?
Yeah, I mean, fortunately, or maybe I shouldn't say fortunately to discredit anyone who is religious, but I'm not religious. And so I don't find any safety in some higher being, or any predefined law set forth by such higher being. However, it kind of boggles the mind to think that that's, how the universe is kind of proving itself to operate. And I guess I could say it's a little scary, not under the pretense that, there's instability in the universe, but rather that there's so much even I don't know even I feel like our top scientists don't know about these fields, and I'm not one to say that, being as maybe not misinformed, but lacking information. It's quite boggling. I mean, and we haven't even had actual tests about this stuff yet, as far as I'm aware. We haven't had any like small scale reconstruction of, okay, let's test relativistic effects at this small frame, and that even gets into quantum mechanics too, if we want to talk about even smaller frames of time, which we haven't even defined insofar as I know. Right? We haven't even come up with anything to define moments in a quantum scale, and so. I mean, if we go to the galactic scale, galaxies in the universe, I guess we have some idea of how time kind of manages on that scale, at least. I think I read somewhere, and there's also a couple videos that talk about how we're, according to what we know so far, right, about the birth of the universe, and looking at how light is hitting our planet from all of the galaxies, that are light years and light years away, parsecs away, God knows how far, that we're in the infancy of the universe. And that the majority of the time of the universe, like the trillions, the Googleplex, whatever the hell amount of years, is going to be just spent in a vacuum, when all of the matter has dispersed and equalized into all the space that the universe creates through its expansion, right? The cold death, I believe it's what it's called, is the theory. And we're talking unfathomable amounts of time, right? And like you said, I mean, a year is arbitrary, especially in the scale of the universe. But man, time is one of those concepts that my brain struggles to really grasp when you look at it from different frames.
It is, and even to your point about the universe, we haven't even figured out how to grasp space. Now, space and time are linked. Let's say, for context, the fourth dimension, every moment we live is a moment in space-time. And then that's the idea where wormholes come out, because if you can jump between these links in space-time, then you are in a different space-time, or at least a farther path forward on that space-time. But every present moment is all we have. We can't even understand just the space part of that, at least not yet, because let's look at the universe, its expansion, as you said. That's accelerating, which doesn't make any sense, given at least a base level of old-school Newtonian physics. It doesn't make any sense. It's now accelerating past the speed of light, and we don't even know where it ends, because the observable universe isn't the entire universe. And if you look at the edge of the observable universe, those things we can see now are going to move beyond our purview, because they are accelerating away faster than light can even get there, and thus bounce back so we can see that light. So just the observation is mind-boggling. But then the idea that their time on that, let's say, galaxy is so drastically different to ours that one is significantly faster than the other, one is moving in a totally different way, you might say. It is mind-boggling, and it's unfortunately not intuitive at all, in the same way that quantum mechanics is not intuitive. The idea that, we can look at the dual split experiment, you can look that up online, or Schrodinger's cat's the most iconic, that you can be in two different states at once, and you don't know the final state until you observe it. It's kind of like quantum mechanics. I was looking into how these algorithms work for quantum computing. And these algorithms try to rely on the exponentially fast duality, you might say, of quantum states that end up with one end result as soon as you observe what's happening. I mean, this is so unintuitive to us that there's no correct answer until the end, and you don't get to decide which it is. It doesn't make any sense at all. Yeah. And if time is functioning in any kind of similar unintuitive way, I can understand why people say, oh, it's a construct, at least in practice, because who gives a shit? You know what I mean?
Yeah, right. And this is just looking at time from 4 dimensions, or rather 1 dimension really, and it's just linearly traveling through it at a single point by point, I guess you could say. So, God forbid we bring that to another dimension where the only like fathomable idea we could come up with about explaining it is kind of looking at it like a timeline and being able to pick, the time, kind of like a number line, from 0 to like -10 to 10. You can go anywhere on that number line from the present to the past to the future, which probably has more people refuting that claim, because obviously we don't live in that dimension, and we're only even hypothesizing it exists. I mean, if there was a higher being, I would definitely believe it to be in that level of existence. Certainly, because with that would come immense amounts of power, being able to see what is going to happen and knowing precisely what already happened.
Well, let's pin that point home, because this is an interestingly relevant argument, I would say, that could support or at least not refute a higher being. Because you might say, well, there's no evidence that we can see, we're human beings. We observe the 3-dimensional world and within this 4th dimension of space-time. So there's no evidence of a God, you might say. Miracles haven't been substantiated, whatever. You could say that. And maybe you would say the same, maybe I would. But is it not fair to say that if there were a deity living outside of this 4th dimension, that by definition, how we understand space-time and its lineage, it would know the future. It would know the past. Now, granted, space-time, the future of space-time doesn't exactly work that way, and I'm certainly not an expert, but through quantum mechanics, there's some randomness in the universe. But even if you just admitted present and past, the things we know that have happened and are currently happening, could a deity not see all of that?
If it was 5th dimensional being, yeah. And here's the thing, I would even warrant calling that immortality, right? And that definitely transcends into godhood by more conventional definitions. So, I mean, just think about it. It's actually quite hard to fathom. If you're in the present moment, you get to select the time, maybe not the place, but definitely... Oh, my brain's farting out just thinking about this. Like, imagine sitting in this chair, and you can kind of like a slideshow, just like drag a slider and go to different points in time, but staying in the same place. Maybe a being of that dimension would probably be able to manipulate space in different ways. I wouldn't know, but you would in essence be immortal, right? And you would know when you die. I mean, would you even be biological at that point? Or would that be a being that's beyond these processes?
Well, this gives credit to the argument, I think it does at least, gives credit to the argument that we could be programmed. Because think about a simulator. You use space simulators more than I do, just in your studies or just for fun. And in a simulator, you have simulated the past, present, and future. Yeah. Again, we have to disregard quantum mechanics to some extent here, but for the sake of argument, hear me out. And then you can, let's say like you're editing something in iMovie, drag this slider forward and back. If that's the case, can you not do something like that in a simulation like a Sim City, where everyone's living, they have their life, they go to the grocery store, they come home? Well, couldn't you just pick a spot, right? It doesn't seem unfathomable to say that with a technology that's advanced enough that we program this entity. Yes, it would be for a human to do it, still in 3 dimensions, still using programming, but from let's talk relativism in a totally different way, from the relativistic stance of a sim who is processing how space-time works and thinking that there's a 5th dimensional being. The programmer is that 5th dimensional being, or at least someone who's outside the 4th dimension. I don't know if calling them 5th dimension is totally accurate. I'm not an expert on this, but you see what I'm saying.
Yeah, exactly. And a lot of the terminology you were using here might not even be remotely correct, but hopefully it gets the point across. Mm-hmm. But I thought about that too. Like maybe we're just like nth degree levels of abstractions deep into species simulating a reality, right? And you just keep going up and up and up until you get into a real, the actual truth. But that's like super conspiracy theorists and all that. But it's interesting nonetheless because, you look at these simulations and they're getting remarkably, accurate and fascinating. And you can only imagine what is going to become of them in the future when our technology is whatever it is. I believe, if we still look at the trends for technology, I think people are still saying we're on that, exponential curve of information.
Well, in that case, time has to be relative because once you're a level of abstraction deeper, your time is arbitrary to the person who's controlling it because they could fast forward.
Yeah, they
right?
can put, all right, let's travel 1 million years per second.
Right.
Yeah.
Now, to your perception in this simulation, if you want to call it, that's fine. But then this brings up interesting points of, you might say, oh, well, then that's the God, right? Any religious person could say, if they want to accept some kind of more general deistic approach to religiosity, that's the God. Well, then the God could be doing the same argument, to your point. It's just another level of abstraction. And it makes me think, could this be the multiverse? And if so, did someone program the multiverse, right? This makes your brain kind of freak out because it doesn't really make sense in our world. And this is obviously just a theory. There's no consensus around this, nothing like that. But isn't that fascinating to think that the multiverse could just be different simulations? But then that wouldn't be a requisite to say there's an infinite number of simulations. Like in the multiverse theory, there's an infinite number of universes, from my understanding.
And like you mentioned, this doesn't even consider quantum mechanics insofar as we know today. Supposing that even what I mentioned here is correct to what's actually being found. But, when you look at a particle under the guise of quantum mechanics, and you're trying to see what state it's in, when you're looking at quantum particles in particular, in what state it's in, and how it collapses. Right? Some particles collapse when you look at them. Is that something that was predetermined, or was that something that kind of a variable, even from a fifth dimensional view, right? Let's say you can control time and you can go back and forth. Are there still these little quirks where you can still, like, I'm going to go into the future, but their variables change. And then you can go back, and then you can go forward, and then variables change again because these particles are acting differently depending on. I actually don't know if they rely solely on perception. Like, is it only when we look at it that it does that because we look at it?
Well, that's the thing. I don't know all the science behind this. To me, as a Newtonian brain, the most logical explanation. Let's look at electrons. When I was in school, just chemistry, I'm taught a certain molecule has 4 electrons, and they go around in circles around it, and then you can look at them and see them move. At least from my understanding, it's not being taught like that anymore, at least at higher levels, because electrons follow these same quantum principles. It's just we call it a cloud of electrons.
Exactly.
And then once you observe it, it picks a spot, because otherwise it's actually moving in a wave motion.
Yeah, and it's a probability cloud, right? Yeah.
And photons are like that, but ignore that photons are like that. Assume photons are linear particles. My best guess, and this is totally uneducated, but it's the only thing I can conceptualize, is that when you observe an electron, something happens at the moment of impact between the photon and the particle, the electron.
Oh, yeah.
Because human observation relies on light. Now, there's other kinds of observation, and I have no idea what other ways we have to observe things and if these quantum principles still hold. But the only thing I can conceptualize is that there's some kind of interaction causing it to stop. It's not the idea that once it's observed, it changes its state, or rather collapses and selects a state. Because that's mind-boggling to me. I can't. Right. It almost gives it a level of consciousness.
It's almost saying that you need sentience for quantum mechanics to work. Right. Because a cow looking at a quantum, you can't even really look at a quantum particle as a cow. You don't have, the technology to do that.
Right.
So, that's actually really fascinating. It actually makes some sense to me because that gives reason behind why it would even do that beyond just mere probability and nature of the universe. You could, I guess, allude to, but
But it's also not wholly random either. It's random which state is selected in some sense. But if you do look at the double slit experiment, you can look at it as wave patterns. Light can work, let's say you draw two slits. Where is the light going to go on the wall behind the two slits? Mm-hmm. Whenever you're not observing it, it will make a wave pattern. Whenever you do observe it, it makes a particulate pattern.
Yeah.
If I have that order correctly.
I believe you're right.
How can the state of existence be dependent on whether or not you know about the states that it's existing in?
Yeah, right? So, and here's the other thing. This is what I was going to get to that I kind of lost track of, but you picked up, fortunately. But I was going to mention how I feel like 90% of modern science is based around, at least if we look at like astrophysics, physics, quantum mechanics, all of it, is determined through interactions with light. Because that is for ages on end how humans kind of interpreted data. And I feel like we're just now getting to the point where we're managing data and collecting data in ways that don't involve light. Like in my astrophysics class, the one class I took all the way, we talked about how 90% of what we figure out about the stars is because we just look at them. The light, the way the light interacts, and the wavelength and
how it's curved by gravitational pulls.
Exactly, right?
Like
that tells you distance, that tells you age, that tells you composition, and through all of those things you can infer so much. And then we brought up dark energy and dark matter, which completely just boggles us because that doesn't interact with light whatsoever. The electromagnetic spectrum is you could get rid of it and it would still be there. So, well, maybe that was a stretch, but it doesn't interact with it. And so we're kind of in this new stage of information, I feel like, where we need to figure out ways to learn things without relying on light as the requirement to observe and collect data. And one of those ways, right, and this is kind of a side tangent from time, but I think we'll bring it back together here pretty soon. One of those ways is gravitational waves. And gravitational waves do affect light, as we see through gravitational lensing, how it bends light. However, you don't need light to observe its effects. And so, we can use that to infer data about black hole collisions and galaxies and stuff like that. So, I mean, all of this is still under our conception of time as it is, how instant to next instant. So, it's quite fascinating, and I think light and time are definitely interconnected, at least in what I know about space and looking at a grander scale. They're one and the same when you're looking at how to analyze data over time.
As unintuitive as it is, it seems to me as equally unintuitive as it would have been for Einstein or someone like that to claim that energy and matter rather, are one and the same. That matter and these bonds that hold them together is a collection of extremely high amounts of energy. And obviously we built bombs that utilize this theory very well, albeit very inefficiently. But at first glance, I can only imagine that would be so counterintuitive until you find a way to experiment on it, until you discover a way to learn about it in more detail. Space-time might be that same way. We might not build a wormhole, if they're even possible, but there might be a better way to, quote-unquote, observe our reality without photons. I don't know.
Yeah. And one of the interesting takes from, I'll mention Interstellar again. I think I remember that the ending to that movie the best. And spoilers for it if you intend on watching it. A few years late to it, but that's okay. So, some of us are. When he falls into the black hole at the end, he transcends dimensions, basically, right? And he can look at, I think, an instant in time that he was looking at to change the future course for humanity, I believe. And how he did that was he kind of interacted with physical objects. I don't know if that much is, possible. Maybe it makes sense since he's still in those 3 dimensions that we live in. He's just now able to pick where he is in time. But regardless, that conception of how five dimensions work, it defies all reason. Especially because you would think he's in the black hole, which is God knows how far away, or whatever higher being there is, from Earth, through the wormhole that they traveled to. I mean, there was a lot of like science fiction in there, but also, science hypotheticals. I mean, they got a few things right in Interstellar, and I obviously watched Neil deGrasse Tyson debunk it. A couple of other big names too. I forget, but it was quite a while ago that I was kind of on this phase of learning about black holes and stuff. But I really can't at the end of the day argue that time isn't real. Time is most certainly real and definitely happening for everything all at once at the same time. And I think that's the whole gist of it.
Well, at different times.
Or actually,
How fast are they
I
moving?
guess you're right. Actually,
So maybe time isn't one thing. Maybe it's
Exactly.
a spectrum. Because black holes, which you know more about than me, isn't it true that as you hit this horizon line of a black hole, light and matter can't go through? But since that's space-time, it's also true that time no longer goes through a black hole, right? Once you hit the horizon, you actually just are stuck. I mean, your brain stops working, I assume, because of some kind of gravitational force, but you're actually just stuck in time. There's no more, if you could still perceive, your eyes still worked somehow, you actually would feel as if you're not moving. Isn't that the case?
if I could fall into a black hole, I definitely wouldn't, but I would love to know what it's like.
Right.
So, like, I'll tell you as much as I know about falling into a black hole. So if you have a supermassive one, like a gigantic one, right, and you cross the Schwarzschild radius, which is the point at which light doesn't come out.
Right.
Those bad boys are gone. Those photons aren't coming out.
Right. Too much gravity.
Yes. And so you cross that on a supermassive black hole that's like, astronomical units in radius. This thing's massive, the size of our, inner solar system. You won't immediately crush from gravity instantly. It's actually going to take you some time before it actually starts stretching you out. Right? You need to get closer to the singularity before the gravity at your feet becomes strong enough to actually pull the atoms from it faster than from your head.
The flattening, right?
Yeah. The flattening.
But how is time affected by that?
See that?
Because my understanding is that time, again, you'd have to be alive to perceive this, which in a biological way I don't think you would be, which maybe I'm wrong. But my understanding is that once you reach this threshold, your perception of time is almost still.
I think that's true.
Is it?
Because I if I recall watching, I think it was a Vsauce video even, there's a simulation of what looking at someone falling into a black hole looks like. And, they would cross the Schwarzschild radius, and they would look normal. And then as soon as they got past, the infinite blackness that is the actual black hole, they would just redshift, and then slowly all of their photons would hit your eyes until all of their photons that were outside of the radius hit you, because now they're in it.
Right.
And so they would just redshift into nothing. But they're still there, behind the veil.
Right. But what would their perception be?
But their perception, so I'm not actually sure how accurate it is. I mean, I believe it quite well. But there's this game called Space Engine. Developed by one guy in Russia. Absolutely insane what he's done. I think actually it's maybe a team of 2 or 3. But, he aims to simulate a lot of things. And one of the things he wanted to get right with Space Engine in terms of simulating the universe is how light interacts with things, especially at relativistic speeds and in relativistic scenarios. And when you fall into a black hole in that, and I believe there's some evidence to suggest this, you can see the universe kind of just collapse into a single blue shifted bubble of light that just becomes kind of like, it's like the light at the end of the tunnel. It's just like a very bright dot. And then, in terms of time, I believe, like you said, time would just kind of be a standstill for you.
Because space and time are
you're
related.
You're kind of like, if we could pull up that graph, if we had a video, let me pull up the graph.
Jamie, can you pull that up?
If we had that graph of, like, how space-time on a two-dimensional plane kind of warps into this funnel. Right? Oops. Knocking stuff over here. Warps into a funnel. You're kind of like imagining a dot being you falling down that hole, and then when you're at that bottom of the hole compared to your friend who's still on the paper, the flat paper, they're probably aging very quickly compared to you. Since for you, nothing's happening.
Right.
But for them, instants are, I don't even know how to describe it. But
are you perceiving that circle of light, that decreasingly small blue circle, because of the photon interaction with the gravity? Is that what's happening? Why it's going in like that?
Or rather, I believe it's happening because more so that your peripherals being consumed by... You're essentially traveling... this is actually interesting because I've never thought about this before, but you're essentially traveling into a sphere of shadow that you can move through freely.
With no photons, right. I see.
Yeah, and so it's kind of just like enveloping your vision, but the light that you did see is being blue shifted because it is being accelerated kind of into your eyes. It's the last photons you saw of the universe.
Right.
So they're being kind of pushed right into your eyes as you're traveling farther in. Which is cool. I wish I could bring it up if I could, but and that's assuming it's accurate. We haven't had a drone fall into a black hole yet.
Even if we did, how would it send information back to us?
Yeah, right?
In theory, black holes, they don't allow photons, they don't allow any information to leave.
Anything on the electromagnetic spectrum.
Nothing.
Those bad boys, actually.
You couldn't
that's a
ever
one-way
perceive
trip.
By definition, unless our understanding is wrong, there is no way to perceive the inside, quote-unquote, past this threshold of a black hole.
No, there actually isn't. No, you're right. I got a little ahead of myself thinking, oh, yeah, we'll just send a drone into it, and then
no information will come out.
No, those waves are being pushed into the black hole faster than they're traveling to escape. So that's one of those mysteries of the universe that either we'll never know or we're wrong about something.
Let me give you a stronger hypothetical that I'm sure neither of us are close to qualified to think about.
Okay.
But let me just say it. You create a black hole, a small one, you somehow manage to keep it not sucking in the world around it, which doesn't make any sense, but hear me out. You have a black hole, you get sucked into it, you perceive it. Something perceives it. Presuming it's on a localized storage base, right? You don't have to send the information back. It's just localized information on, let's call it a drone, although I'm sure that wouldn't be what we'd do. And then you turn on another black hole next to it that's stronger, and it pulls you out of the first one. Then you turn off that second black hole, you still exist, and then photons start interacting again, and now you have localized storage of what it was like to be inside the first black hole.
Wow, so you're saying black hole, other black hole, you're in this one and it absorbs this one and pulls you out of it.
Right, like only the first one exists, because in theory, humans are very young. So let's admit that we're now thousands, millions of years in the future, and we have way better technology where we can create a black hole.
We black holes when we want to.
Some kind of, I don't know if camera is the right word, but some kind of detection device goes into one, and you can't get information out of it. That's why it's localized storage. But it hasn't been destroyed by the black hole yet. Presuming that's possible, you can perceive it in the amount of time it takes before you're destroyed. And then you either turn off that first black hole, because we created it, or you have a bigger one that pulls you out of it, and somehow you can disassociate from the two black holes. They get isolated in a room or a part of space. I mean, I don't know what kind of technology we'll have. But either way, you go in it, you haven't been destroyed yet, you've perceived it, and then you're back out of it. This is just a theoretical, if we had the sufficient technology, which I suspect we never will, then you would know what it's like to be in a black hole.
Yeah, because you got pulled out before it. That's actually impressive. I'm also thinking about, because I'm just going through the basic equation for the force of gravity in my head, right? And how it's mostly determined by radius. You need a big secondary black hole to suck you out from almost being consumed by the small one. That would be a crazy experiment.
Unless we could turn it off somehow with some kind of weird understanding of dark matter and dark energy that I don't understand at all.
No.
Because that's, correct me if I'm wrong, the reason that this acceleration of the universe is happening. That's our best theory right now, is it not?
Yeah, it's just something we can't see. It's literally on the level of like religion. Yeah. I mean, in terms of like, we don't really have how do I say this without being rude? We don't really have like substantial like, oh, here's actual proof this happened. Here's a picture. Here's a photo.
Right.
Like our best evidence is just saying there's something out there and we think it exists because we can't explain it. You know, it's on par with like, oh, you know, we got good harvest this season.
Right.
I can't explain why. Maybe it was the gods.
It is odd. Although people will often use that as a counter argument and say, well, in the same way I have faith in Jehovah, you have faith in dark
energy.
Right?
Dark
Whatever
matter.
it is.
I mean,
the difference, I would say, though, although this is somewhat off the topic of conversation, but I think it's pertinent, the difference is there's a pursuit to solve it.
yeah.
And I think with
Exactly.
the path forward, with the scientific method, let's say generally, there are ways to solve it. Because this hypothetical I just gave may never be possible. You may never have some kind of sufficiently strong perceptual gauge that goes in a man-made black hole and then we turn off the black hole or we suck it out with another one. That may never happen. But at least there's a way to try to reach these conclusions. There's a path forward. The same way that energy and matter are so tied together, you could argue they're almost the same thing in some ways. You know, E equals mc squared. You can look at these equations and say, this is amazing, and it's so counterintuitive. The same way I think quantum computers and these quantum algorithms will do over the next 100 years. The average person is no longer going to be able to intuit them, and maybe they never will. Maybe it won't be like Newtonian physics that the average person can intuit with enough knowledge and enough training. Maybe we never will, but it doesn't mean you can't continue to pursue it.
Yeah, and I to be fair to, you know, my analogy, yeah, I definitely give more credit to dark energy and dark matter more so than some deity being behind it. Also because it's based upon the backbone of so much other things that we've already spent many hours trying to figure out. And so back to dark energy and dark matter, right? The invisible force behind why so many things are happening that we can't quite explain. I mean, the other thing too is that if you ever look at how the galaxies and the clusters of galaxies kind of form a kind of a web. It looks a lot like a web when we look at it in space. You know, gravity shouldn't be strong enough to hold these local clusters together. If you do the math, they should just disperse, and then, you know, they shouldn't be collecting in these kind of this structure that forms where all of the matter kind of collects in the universe, which is where we get dark matter, right?
Well, on a short time scale, I assume you mean. Because theoretically, in a long, infinite time scale, if you don't have an acceleration, because that would be explained by dark matter or dark energy, then eventually gravity would have the big crunch.
Exactly.
I think is what it's called. But that seems to be decreasingly likely. So you mean on a localized, a short time scale, they shouldn't make this formation.
Yeah, even in a long one, they shouldn't, but also because the universe is expanding, they're creating the web at the same time.
Right.
So it's quite crazy because if you go far, far into the future, the web will actually dissipate because the expansion of the universe is actually going to push everything so far apart that all that will be left for us is just our local group of galaxies, actually. If you go far enough into the future, where gravity is just strong enough in our local group, so this galaxy, the Milky Way, Andromeda, the large and small Magellanic Clouds, all the little guys, I think Triangulum. If they all merge, they all will merge from gravity, and that will be all that's left of us. And because of the expansion of the universe, all of the other big groups will be too far for us to even explore, right? And you know, that's another crazy thing too. I guess I'll bring this up now in terms of the amount of time it takes to explore something, right? So Voyager 2, which is, you know, every year they come up with a reason why it's still not out of our solar system. You know, like 10 years ago, it was like, oh, it's still in the something cloud of our sun. And then now it's like, oh, it's still in the something cloud of our sun. You know, the thing will be like 700,000 light years away from our sun, and they'll still say, oh, it's under the influence of our sun. I mean, of course it is.
Well, yeah, it will forever in some theoretical sense.
Actually, I mean, to be fair, you can make the argument about something that's 12 billion light years away that we're under the influence of it, which, I mean, you could argue is not wrong, but...
I was going to say, to that point, isn't that true that, from my understanding of gravitational waves, they are infinite. There's no smallest, like, you go look at an atom, you get down to its, individual, you can even go down to the quark level. But there might not be a sub-quark entity, or at least there may or may not be. But with gravity, isn't it the case that it just gets decreasingly small forever? There's no
zero.
You've reached a threshold where there's no influence from gravity?
Exactly, right? It just depends on how precise you want to be.
Right.
Like, there's no scientist out there that wants to say, okay, let's go to the negative 100th power, you know, to see, if it's influencing something.
It's not practical, right.
Precisely. And so, but it's also true that we're still being influenced by things that are at the edge of our observable universe. Now, I don't know if I can make an argument for things outside of that, because...
Well, does the gravity still influence us, even if the light never reaches us? I don't see why it wouldn't.
I would think so, right? I mean, I don't think gravity is bound by
light?
Speed of light, right?
Well, certainly not. I mean, black holes don't have any light
instantly, in them. Right? And it will instantly have that force. Right? There's no like, oh, you need to travel a time frame before gravity starts affecting something. As far as I know.
Well, we could do an experiment. What is this called? I always forget the name. Where two particles are quantumly bound together.
Entanglement?
Entanglement.
Yeah.
Let's go another crazy Colton hypothetical. You could just have a quantum entanglement beyond the observable universe and see if light has any effect. My clear intuition is that no, it would still be quantum entangled.
Right.
We just can't observe the entanglement.
And tunneling too. Right? I mean, I think I've read somewhere that a quantum particle can just be instantaneously in another location and then back. Right? I mean, who's to say that location isn't on the other side of the universe? I don't think those are bound by speed of light, as far as I know.
No, it's absolutely not, because it's instantaneous.
Oh,
yeah, quantum.
I guess you're right. Yeah,
it is. This entanglement is, from my understanding of every research paper or article or documentary, or very little of my own study, admittedly, it's that they are entangled in a way that's, again, not intuitive. Let's bring this back to time. This is instantaneous entanglement of particles at any distance, from my understanding of the theory. At any distance. Imagine you have two particles that haven't collapsed yet, unless my understanding is just wrong here, that are God knows how many light years apart, and then, you've observed it, it has to collapse now in a certain position.
Wow. I mean, if that's the case, talking about time, what instantaneous interval do we have to go to
it's
even
not an
fathom
interval.
that?
There is no interval.
There is no interval.
Zero. It's zero.
So in instances like that, time does not matter, right?
No, unless you count the time 300 million meters per second of the photon to hit your eye
the
or whatever, to observe it.
Yeah.
If you want to call that level of time. But the collapse itself, from my understanding of the theory, and again, I'm not a quantum physicist, so don't quote me, but from my understanding of the theory, is it's instant. It's not a super small amount of time. It's zero. It was observed. It happened. It collapsed immediately. It doesn't fit with our understanding.
Yeah, and so then that just goes into the realm of, well, oh man, that's interesting. So time doesn't matter. In those instances, we could argue that time doesn't matter for some instances. So like all that matters there, right, is if the photon matters, right, in this hypothetical, that photon travel time is all the interaction you would need for anything to happen.
It's not, but is it traveling? Because travel, from our understanding, let's look at Newtonian physics, is distance over time. I mean, that's your speed. That's your speed of travel. This is just the equations you learn in intro to physics.
And that's if we're looking at photons as a particle. Right.
It's not traveling if it's just, to say appear is probably an ignorant way to say this, but if it's just realizing in one specific instant in space-time, it's not traveling between instances unless it's traveling infinitely fast, because there is zero time passing. It would have to be traveling orders of magnitude faster than the speed of light, depending on the distance.
Yeah. Light years per microsecond.
Right. Newtonian physics equations totally break down. And to be fair, an understanding of Newtonian physics has already been better understood by general relativity and better understood more by quantum physics. I admit that, and I admit my ignorance, but the whole intuitive side of physics breaks down. It doesn't work. It doesn't make any sense.
And this is still going under the observer effect, right? And I haven't read enough into it, but this is assuming that in order for the observer effect to even take place, right, for a particle to collapse, that there needs to be light present.
That's my understanding as well, but
yeah.
that could be wholly wrong, and I wish I knew more about that.
If light didn't even have to be present, then yeah, as soon as your sentience expects something, I don't even know how to describe that.
We are giving Deepak the best marketing campaign. As a man who thinks molecules have consciousness, we are doing him a lot of favors right now.
We're really sounding like we rigged it from the school of Deepak here.
Certainly.
We definitely don't, but
okay, let's go back to deities here.
Okay.
Because in America, I mean, a large portion of the country believes these are deistically influenced, and I want to give credence. If something is outside our understanding, and if we can never understand it, which I'm not saying is the case, is it equally plausible to say something, let's call it outside the fourth dimension, is creating an imposition on our reality? Like, what if our reality really is more Newtonian than we accept, and every deviation from that is actually just influenced by something beyond our reality? It's actually not intrinsic to our four-dimensional reality. It's an imposition by a deity, let's say. Now, to say a godlike figure is deciding every quantum particulate and how it reacts is to give it credit as being something that is nothing humanoid at all. And that's not really exactly how people envision a god. But nonetheless, could quantum physics be purely impositional by a being or a program or something outside of our reality? And actually, no, Newtonian physics, that's us. That's all we have. The rest is something else.
So you're saying that when I look at that particle, it's a higher being that kind of toys with that interaction.
It doesn't even have to be a being. It could be...
Or something beyond our comprehension is what you were saying, right?
Sure. Maybe we can never comprehend it. Now, everyone working as a computer scientist in the quantum world creating these algorithms that work would say, Colton, you're an idiot. But it makes you think, and I know nothing about this, but there's more than 4 dimensions. I mean, we have theoretical equations that go many dimensions beyond this that are so far outside of our understood reality, but the math seems to check out that they have some kind of influence. Mm-hmm. I don't know. It seems possible to me that these arguments that, well, even if it's not theoretically true, insofar as practical concerns exist, why do we care if it doesn't affect our reality in a meaningful way? And maybe that's a bad imposition to say, because now we know quantum mechanics can be used for computational power. So maybe it's not arbitrary, but at a certain point it could be. Why not just say it's a god and just move on with their lives? You see what I'm saying from a practical perspective?
Yeah, because I feel like maybe I'm also wrong here. But we're getting to a point where we're going to need to have to, at least in some way, abstract these leading ideas about science and how, these boundary-pushing methodologies on data gathering and analysis. I'm kind of beating around the bush here. Quantum mechanics and large-scale astrophysics and cosmology, And maybe not even large-scale cosmology, because we've kind of abstracted that enough to understand it well enough to have pretty decent feelings about, oh, okay, this is how things are going to play out. But in quantum mechanics, that's really the world. I feel like we're just fucking, excuse my language, we're just freaking, throwing darts in the dark here and just, trying to figure out what the heck is going on and make sense of, and make heads and tails of this world.
But the math checks out.
Right.
In many cases.
And that's why it's so freaky, because it kind of goes against how we've conventionally done things. We've conventionally done things by, okay, let's observe. Okay, that's how it works. I hypothesized this. There was this much room of error. Let's correct and then observe again. Okay, we're on the right track now. I mean, that's how we did it with the sun. How did we learn that hydrogen fusion was how stars work? Because we looked at the sun and we made a hypothesis that was, okay, the only way we could get that, spectrum of energy at these levels and these intensities, if we're looking at photon emissions, is through hydrogen fusion. And we did that through making multiple hypotheses, and they checked out because every time we looked, we got consistent, easy to understand readings over time intervals. And you go to quantum mechanics, and with what I know, it's that kind of methodology is kind of a little wonky.
This might be the best proof for evolution. Hear me out. The argument against it, let's just say young Earth creationism, something like that, has a requisite that Earth, or the greater universe, given that no one believes in geocentrism anymore.
I hope
but
not.
The Catholic Church has finally come around. But it requires humans being this imposition on the world. And I'm only saying this because a large portion of the population, at least in America, a large minority still thinks this is reasonable, and fair enough. But if the world, the universe, space-time, dimensions, if all of this is so counterintuitive to humans, that's the best credence to the idea that it wasn't made for humans.
I agree.
Existed, and then humans, we developed consciousness as some kind of advantage in the evolutionary world, something of a Darwinian benefit, and it feels like we should understand it because consciousness is so different from like having a third leg or being really tall or being vegan.
Having really good smelling capabilities.
Whatever it is.
Yeah,
it can hear really well. Echolocation, which we don't understand. But consciousness allows us to have metacognition, which is wholly unique to us or potentially other mammals. I don't know the science on this. But so it feels like it's made for us. But the idea that we are so shit at understanding it, we can't even understand exponents. The amount of, I've seen some studies on this, of how terrible we are at understanding exponential growth.
Oh.
Just a basic mathematical function, like
1,000's
really big, and a trillion's also pretty big. No.
Trillion
Jeff Bezos is farther away from your millionaire neighbor than you are from the millionaire neighbor by an order of magnitude. No one can really conceptualize that as humans. So it seems perfectly clear to me that since we're so piss poor at understanding, especially quantum mechanics or farther dimensions, but the math checks out. I mean, everything seems to make sense, at least on a framework level. Then maybe it wasn't made for us to understand. You think a deity couldn't just made Newtonian physics be the only truth, and there's no quantum entanglement, that light doesn't curve around gravity? You couldn't just made it a little bit easier for us?
Certainly, if he was merciful, he would have, at the very least.
Is that compelling to you? Because to me, that seems obvious.
As proof against some greater being behind all of it that's in favor of humanity, yeah, certainly. I would think we would have... I mean, we have the tools. It's just hard as hell. And you're right. If there was some merciful God out there that created us in their image or whatever, and they were of higher being, a higher dimension, and they wanted to guide us towards, some righteous, holy path of understanding, he should have made it a hell of a lot easier to understand quantum mechanics. And
you would think.
Yeah.
If we are really in their image, implying something of a humanoid image, they're pretty certainly a computer programmer.
Yeah.
Because I don't know any other planet on the universe, and obviously we don't know all the planets, but we haven't seen signs of life yet, and we can talk about the Fermi paradox some other time, but there's nothing humanoid that we know about the universe. It's not anthropocentric in any way, but if, a god made us in their image, a humanoid image, if that's what that means, that might just be an Easter egg in the game.
I'd be horrified if that was the case. Actually.
That's just the programmer giving us clues.
Ooh. Yeah.
Nonetheless, time is crazy. I would say it's not a construct. Yeah, units of measurement, seconds, minutes, all that.
Arbitrary.
You made that up, but time is certainly not a construct. But I'm also not convinced, just through fleshing out our conversation here, that it always is applicable. Quantum
agree.
entanglement doesn't involve time, as far as I can tell.
I used to think that time was a kind of a prerequisite for the universe to exist, right?
Well, what is existence?
A single instant, is it not? I mean that's my train of thought.
Well, existence. Okay, let's unpack this before we finish talking. In my eyes, something is existing if it, conscious or otherwise. Let's just start with conscious. If it's like to be that something, what is it like to experience this? What is it like to live in this way? Well, this existence has a requisite of experience, which requires time.
I see.
Are you existing if there's no time? I mean, how can you experience? You
I mean,
see what I'm
certainly
trying to
quantum
say?
particles do, right?
But they exist throughout time. Once they collapse, they're still existing.
True.
Do they not exist in that moment? Well, no, they still exist.
They still exist. So, okay, yeah. I was going to say that time is kind of like a law of the universe, kind of like a rudimentary force like gravity.
Right.
And to call it a force isn't necessarily true because it's not interacting in things akin to a force, but it's definitely one of the it's like one of the backbones as well as space, right?
It's a framework. That's how I viewed it. Right.
That's always what I picture when I look at the textbook rendition, and it has like the grid and the planet is sitting on it. It's kind of warped. I always look at it like that. Except imagining that in 3 dimensions is ridiculous. How it warps, I don't even know. I'm not even going to fathom trying to do that on this podcast because I would just make a fool out of myself.
I'm sure I already have in this podcast, so don't be embarrassed.
Me too. Whenever this blows up and we get like astrophysicists and quantum mechanics viewing this, they're gonna be like, "What are they stoned?"
Quantum mechanics. They fix your cars before they
collapse.
collapse.
Not even quantum physicists.
Right.
I said quantum mechanics.
When your car collapses into a state of quantum into a quantum state, you call the quantum mechanics to come fix it.
Oh shit! They're gonna fix my quantum computer. The geek squad of the future.
They're called quantum mechanics. Let's trademark that.
Yeah, we should call them quantum mechanics. That's a good. I'd
that.
apply for that. Yeah, that's a good
But
job.
okay, well, if space and time are the same, and there is no time for a particle to collapse, is it in space? Well, of course it is. It's observable.
Yeah.
But there's no time. How is it collapsing, right? Quantum mechanics is just so unintuitive. But I think you have to have time for existence. By definition, what is existing without the passing of time? It doesn't mean anything.
Yeah, you can't really fathom that. I mean, like, you can. It's a still frame. It's one single instant. But, like, without any prior instance, then there would be no single instant to follow that, right? So there would be nothing.
I see. Because time is an infinite collective of infinitesimally small instances.
Yeah.
So in some sense, there is an instant of time.
Yeah.
But there's not time throughout that instant.
Right.
That's the distinction I want to make.
Yeah. Okay, that's fair. I agree with that. I don't think none of this would exist if there was no prior instance of time.
Right. It's a collection of instances.
Yeah.
There's no Big Bang if there's one instant.
Yeah.
Even if the bang happened in an instant and there's something to do with quantum
the Big
particulates.
Bang is that instant. It's just that kind of whatever it is in that instant.
Right.
You know? And it is that forever.
There was no time. There's no expansion. There's nothing. Which we really should call it the Big Expansion. The Big Bang doesn't really give it credence to what's actually happening. But
yeah,
that's a different conversation.
Oh, Big Bang. Oh, what an interesting. Yeah.
The big acceleration.
Day.
Right.
Another day.
This is going to take me 4 more years of degree hunting to...
It's going to take me 12 of going through my degree, getting a job, and then probably coming back for a master's degree. And
then coming back on the podcast?
Yeah,
After you've done all of that?
So it's going to be 12 years.
Let's pick a date in 2034. Let's pick a date. Nonetheless, This was a super interesting thought experiment-filled conversation that I will happily say I am wholly underqualified to have, but that's the beauty of it. Because if it's this new domain that's unintuitive, well, maybe the creative minds that aren't the physicists thinking linearly, mathematically, maybe it's a different perspective that'll actually come to the right conclusions. I think that's certainly possible. So I think it's worth having these conversations.
Yeah. I agree. I think these conversations kind of spark the curiosity that are required to really go hunting for the details. And I think they're definitely they're a requirement, I feel like, these days. If you keep having conversations like these, then it makes giving reasons to hunt for the answers much easier.
It's a catalyst, to say the least.